Hey, folks, welcome to the show. Hello, Sharad sir. How is it going? And before you say anything, today again, we are today delving a bit into the real world through this show, right? We're going to talk about
Real
hardware,
world, but
real things.
real world being consumed on smartphone devices powered by lithium-ion batteries.
Yeah, I mean, it's as real as it can get. And no, it's very exciting because it's very rare that we actually talk with the operators within the clean tech or renewables domain in general. So quite excited to have with us Vikrant Singh, co-founder and CTO of BATX Energies. BATX essentially recycles used lithium-ion batteries to extract the juice in them, the rare earth metals, which make up most of the cost, which kind of drive them. Things like lithium, nickel, cobalt, manganese, and so on. BATX then supplies, as per our understanding, the recycled elements back into the value chain. And they obviously have a R&D center in Gurgaon. They also have an industrial unit. So welcome to the show, Vikrant. How are you?
Yeah, thank you, Nikhil. Thank you, Sharad, for inviting me on this platform. And I think I would love to discuss about the things which we are doing in terms of, because everyone is now using smartphones, laptops. So I think we would love to chat with what happens to these batteries when you throw it out from your phone when it's come to end of life. I think that is something which I would love to discuss.
Great. No, thanks, Vikrant. Would love to, let's delve deep into the problem statement here. I mean, effectively, obviously, lithium-ion batteries are kind of omnipresent, and there is obviously there is a supply challenge which comes with manufacturing lithium-ion batteries, and then once they have been supplied and they have been utilized, their disposal from the standpoint of the environmental implications again is an important part of the problem statement here. So would love to kind of understand how you got into the space.
I think the whole journey we have started, it's a coincidence that how this BATX is started. When I and Utkarsh is one of my co-founder, and we two have started this company when we were in college. We belong to the same college, Bayon Munjan University. And I was in second year, he was in third year. And I am a mechanical engineer from background. So I used to build the electric vehicles or the gasoline vehicles for racing competitions. So we started building the vehicle. The whole team was, and we was 25 people. I was the president of automobile club in the college. And the event was supposed to happen in Singapore, of event called Celico Marathon. So when we have started building the vehicle, the major challenge that point which we have faced, I asked Utkarsh that I want a battery because I was a technical person. I always loved to build the technologies. Utkarsh was someone who was always handling the operations in terms of management. So I asked Utkarsh that I want a battery which can run this vehicle. I have given him the specifications that this is the specification, please get me the battery. He took 3 months to find out that there is no battery which is being available in India.
This is which year?
For electric vehicle. This was 2016. Okay. I was in second year of my
so still early days. And,
yeah, very early days. It was very hard to find the lithium-ion batteries, especially for electric vehicles. We were only knowing the batteries which were into the mobile phone and laptop. The concept of electric vehicles were very new. Yeah. And it took 3 months because that this is not available in India. We have to close that whole project because the cost of battery we are going to import from Korea or China will be very high. So then the whole project cost was 12 lakhs. Out of that 12 lakhs, 8 lakhs was the battery cost. Mm-hmm. Mm-hmm. And then the whole idea we and I and Kurz and the whole team has set together that there is something we need to do with the battery because vehicle is something already existing in India. These batteries are not being built in India, and that was a time and turning point that we have to do something with the battery. So we have started our company as a cell manufacturing, that we will build the battery in India.
No, Vikrant, sorry. Yep. I mean, because our listeners might not be very familiar with the basic mechanics here. So effectively, when you say a battery, I imagine a battery is kind of composed of multiple cells. And if you can kind of just give a bit of an explainer on the structure of a battery as well, and what are the main constituents, that would be super helpful.
So let's take a battery. So battery is having 3 components. One is the packaging material like safety materials. Second is cells. So there are small cells. For example, if I take an example of maybe electric car battery, so it contains thousands of cells. For example, Tesla, it contains 7,000 cells to build one battery pack. So there is cells which when you combine bit number of cells, it will form a module. And then there are certain modules which are connected together to form a battery. And then the battery is equipped with BMS, battery management system, and other packaging material to package the cells.
So, like, just now for context, like a mobile phone would have how many cells in its battery?
Mobile phone is having one cell.
Okay.
So you can consider 7,000 equivalent to mobile phone cells are being equipped together, assembled together to form one battery.
Understood.
And Vikrant, we sort of keep reading that cells are not sort of being manufactured. No one's in manufacturing in India. We sort of import the cells out of, let's say, China. And what Indian battery manufacturers essentially do is sort of package it together and bring the three pieces together and create a battery pack. Is that understanding true? Because you also said you wanted to sort of manufacture cells. So what is the bottleneck here and how does one go about that? So you can see you are very correct that even today's time, it was 2016, we are landing 2023. In today's date, there is no one in the country which is into cell manufacturing. 100% of lithium-ion cells are imported from China, Korea, or maybe other countries. We don't manufacture these cells. And then what we do is right now, we import the cells from different countries and we assemble this in a multiple cells in 1,000 or maybe 100 multiple cells based on the battery design. And then we only assemble the cells in India, or battery in India, right? So that is happening in India, but I think till 2025, 26, you will see there are certain companies which are coming to cell manufacturing. But at today's time, there is no one. And the bottleneck is the materials. These batteries contain a critical materials such as cobalt, nickel, manganese, lithium. So if you see India as a country, we don't have any three materials. We don't have cobalt, we don't have nickel, we don't have lithium. So that is the major problem of India. We are not able to, because we don't have a supply chain of the natural resources. And these resources are available very, very geo-specifically. If you talk about lithium, it is only having 3 to 4 countries like Argentina, Chile. These are kind of countries contains maximum of lithium. Then if you talk about cobalt, Congo is having the maximum cobalt. So it is the problem is the natural resource, which we don't have. No wonder these countries are now in the expanded BRICS framework. When you talk about Congo and talk about Argentina, so clearly there's anyway, sidestepping. But yes, no, I understand your point that those are rich in energies, rich in those minerals, and that's fine. Okay, sorry, go ahead. And so then you sort of decided that we were initially going to manufacture cells, and you understood the complications there. And how did that sort of pivot into recycling the batteries? So it is a story that I just passed out from the college. We will say that now we have not set in the placements. So right after the college, we realized that without money you can't do anything. So cells are something which can't be built because it's a very heavy capital intensive. Second, you need a lot of capital. For an example, small setup, you need at least 200 crores to set up a very small unit. Second is, you don't have a material to build the cells. So even if you build a technology also, you are dependent on the materials. So 6 months we roam around that what need to be done. We said that, okay, we can't do business out of it. And we don't have money at that point of time. All the pocket money which we have ran away. So I and Kurz just stayed together. We've taken a small room. And then the whole thought process came out that, okay, if we can take the material from existing cells, then build the cells. So it was thought of building the new cell that we will take out the material from old cells and then we will build the new cells. But after doing the research, started the research in the college, IIT and different multiple institutions, we have realized this is a sector which is itself a very big section. So then we put our whole focus on, and then second is that when we met our first investor, Hero MotoCorp, we have, pitched the whole 2 ideas. One was that we will build the cells, we will extract the materials. So they were very clear on the day one that you do only one thing. You have to choose one, that is recycling. Don't talk about the battery manufacturing or cell manufacturing. Then and only I am going to fund you. So that was something where I said, okay, I want money. If you want to do a recycling, I can do a recycling. And then we have chosen recycling, 100% focus in 2020. That when we have started this whole project. And Hero Showroom Partners was the first one who believed in us in terms of they have given the first funding of 2.5 crores. So that was a turning point for us, and we started the recycling, taking of the battery from the market, testing it out, what is happening in the batteries, what kind of batteries are there in the market, how the supply chain can be set, because earlier there is no supply chain which was running in the market. And there is no recycler in today's time also which is actually doing recycling on commercial scale. So what China is doing, they were selling the cells to you, and they were also taking the scrap cells out of their country.
So essentially you were saying that
sort of recycling of existing batteries, right? It seems like a very complex and capital intensive endeavor, right? I mean, you're talking about flammable materials. How does like, what was the R&D process about it, and what did you have to set up a manufacturing plant initially to sort of test the thesis, and actually how does that process work of actually extracting rare earths from discharged or from an expired lithium-ion battery? Right. So if you start from the stage one, you also see that these batteries are very flammable, right? Sometimes they catch fire if you do something with the battery. So this was the problem, which was very complex in terms of even touching the battery, right? Even if you are opening the battery, you will be facing a lot of hazards. While transportation, you will feel that there is a lot of firing which will be happening. So we have started this whole project in 3 colleges. IT Delhi, because IT Delhi is equipped with certain equipment which is needed to test the battery. Then Munjal University, where they were having the nanomaterial science research for researching the nanomaterial. And third is CSIR. So all 3 universities we have collaborated, and we have started the research from very basic, that what is inside the battery. Because you see that if you want to test what is there inside the battery, you need crores of equipment. For example, this battery contains lithium, cobalt, nickel, manganese, right? When you open the battery, it will look like a crushed coal, black kind of material. So by tangible, you cannot see anything that what is this batteries contain. So you will be needing scanning electron microscopies, you will be needing Raman spectroscopy. That is that these are testing equipments which can tell you that what kind of material is there inside the battery. For an example, when you put that material inside under the machine, it will tell you that 15% is lithium, 20% cobalt. So that machine itself costs around 5 to 6 years. A single machine. Then you will be noting down the particle size of the material, then what is the composition of the material. So this was a very high challenging problem, because we were not having money. So I especially first learned how to run the equipment, because we were incubated in these equipment, so we don't have to put the charge of the machine. You can use the machine based on the time. But then we have learned the whole machine for a year, put a training that how to use these certain type of equipment. There were 8 to 9 equipments. And for single equipment, you will be needing at least 1 lakh rupees per month person to run the machine. So that was something which was very problem, that how to do it. Then we learned the whole equipment, how to run it, how to repair the machine, because sometimes you have to put the charge if something happened to the machine. Right. So that was the time when we were planned, and then we have started the whole research that what kind of battery content. We have generated a lot of reports. What batteries, mobile phone batteries contain, what is the content which is there in the laptop phones, telecom industry, power electronics, electric vehicles, and then coming to the commercial storage. So these batteries applications are very, very wide, right? And every battery is very different. You cannot recycle every type of battery with a single technology.
Right.
So first we have generated the data, and then we have started building the whole technology.
So once you have kind of figured out the composition, like let's look at your current use case, right? Which I guess is dominant on EV batteries, correct? So I mean, once you have kind of figured out internally, right, what is the composition, then what's the process of extracting or harvesting the material out?
So first of all, we need to understand the structure of battery. In layman terms, I want to tell you that. So in the batteries, what is happening? You have 3 layers. One is you can say cathode. Second is separator, and third is anode. So once you put up your phone on charge, right? So what lithium does is lithium comes out from the cathode and it runs behind the anode. So there are a lot of, you can say, space which is available in the anode side. Right. So once you put the charging, all the lithium ions they got into the excitation stage, and they are residing inside the holes which are provided on the anode side. When you discharge, again they have to come back. Got it. So this through and fro motion is happening all the time when you charge and discharge the battery. Now the problem is when you charge the battery very first time, so maybe 100 ions moves from one place to another place. So all the ions are not able to return back.
There is some loss, right? Every time.
So every time there will be some loss. Right. So because of that, there is a deterioration of the capacity inside the battery. Got it. So that is a simple reason. Second is, if you see the battery structure, it contains cobalt, nickel, manganese, lithium, copper, aluminum, plastic, some electrolyte. This battery also contains some liquid, which is called electrolyte. So why this liquid is being used inside the battery? Because once you charge the battery, so you need some media. For example, if you are running in a solid state, you will not be able to reach on time, right? So they are providing some liquid media to swim that ions to reach from one place to another place, and that is highly flammable. So it just started from. So we have built the first plant in India in 2021, which was the half of the process of the battery recycling. So because this process is very complex. For example, if I tell you to build a whole plant, at least you need 50 crores of money to build the first plant. So we were receiving the very small money. We have made some jugaad kind of thing from IITs, from different institutions, from workshop to make small equipment to place you can say a pilot plant. So pilot project was something where we can put 10 kg of batteries, and you can get the material based on the 10 kg. So we have made the full small machines in-house by taking the conferences by attending a lot of conferences in China, Singapore, in Korea, Europe, and understanding what they are doing into the process.
But like in the process, there must be like some
inside the.
I mean, in the process itself, there must be some there must be some mechanical separation. Then there must be some chemical process that will also come, right? To kind of
coming to that only.
Yeah.
Coming to that. So first challenge is to how to crush the battery, because when you will crushing the battery, it will catch fire automatically. So first the battery will go for the discharging media once the battery is being brought. So we are dissolving this whole battery into a solution. So we'll put these batteries for 4 to 5 hours for neutralizing the charge inside the batteries, because you don't know when you throw your battery, it may be charged, maybe 100% charge, maybe 50% charge, correct? So we used to first neutralize the charge, and we used to make discharge 100% in the first stage.
Got it.
Then we do a mechanical separation method where we put the batteries on a conveyor line, and there is a shredding unit, there is a crushing unit, there is an airflow separation, there is a grinding unit, there is a sieving method. So there are 16 mechanical processes where we separate the cathode and anode material, that is the material which produce charge, and the packaging materials. So that mechanical process only does the separation of the cathode and anode, that is called black mass. So black mass is something which is mixture of cobalt, nickel, manganese, and
that's the most valuable part.
That's the most valuable part in the battery.
And like, what do you I mean, when you're looking at, I assume that there must be some wastage, right? I mean, the amount of lithium, cobalt, manganese, aluminium that was there in a new battery, when you're harvesting it out of a discharged battery, how much of it is actually usable or reusable? Like in terms of
it's more than 98%.
Oh, really?
So as I explained that how battery functions. So when this charge, then these ions are not able to return back. That is, there is no material degradation which is happening in the battery, right? There is a reaction phenomena. Because of the reaction phenomena, the battery got deteriorated. So it depends on the technology. So right now our yield is 98%.
Right.
So it is a technology failure. The 2% which is we are not able to recover, it's because of technology. But over a period of time, we will see that we will enhance the yield. So theoretically, you can extract 100% material and you can reuse in another batteries.
Right. So once you have the black mass, then I mean, black mass is there has to be some, I guess, overlaying process on top of it, because I don't know whether it's because that sounds like a composite material which comes out, right?
Yep. So this is a composite material in form of oxide. It's called lithium coal manganese oxide material. This is a very small process. Now it comes to a complex process, which is chemical process.
Right.
So in chemical process, we have mostly companies are following hydrometallurgical technologies.
Right.
That means they are using chemicals to extract these materials out from this black mass. So that process contains 158 stages.
Okay.
To extract the materials like nickel, cobalt, manganese, lithium in form of salt or in form of metals. Based on the customer requirement, we extract these materials with a purity of above 99%.
Right.
And these materials is 100% reusable in the new batteries.
Interesting. And once you get that black mass, that you again have to sort of study the composition ratios of each metal. Does that significantly vary from the initial composition of the new battery as well?
Absolutely, it varies, and every time you need testing because when these batteries come, for example, your mobile phone battery contains different materials. Maybe some other mobile phone battery company contains some other materials. For example, if I say Apple contains 30% cobalt inside the batteries. It contains 4% lithium inside the battery, right? If you see Samsung, it contains 20% cobalt and pretty low lithium inside the batteries, right? So that is a difference in all kind of battery ranging from mobile phone to electric vehicle battery. So now the basic challenge is how do you know what kind of material is inside the batteries? Because when you extract the materials from black mass, you should know your composition.
Yeah.
So then we test. It is 100%. I know testing is being done in terms of when we extract the black mass. Again, the black mass goes to a inductive coupled plasma mass spectroscopy testing, and that machine tells that what is the composition of this material, what is the composite form, maybe in oxide form, maybe in some other carbonate form, other form. And then we proceed to the plant stage to go for the chemical operations.
Understood. Now, from a business standpoint, right, you've done these processes and you've extracted out, let's say, nickel, cobalt, lithium, and manganese. Now, from a business standpoint, what is the next play? How do you think about, we have the material now, let's rebuild a battery or rebuild a cell and sell it as battery, or why not sort of sell it at wholesale rare earth level? There must be buyers of, like, how do you make that business decision, and what is the angle here of using that as input material or selling it directly?
So at the current moment, we are selling the material, we are exporting it to different countries like Belgium, Singapore, and other countries. The basic problem is that India don't have any consumption of this material because we don't build the cells in India. So there is no supply chain of any materials to use this material.
Yeah.
Right.
Second is exporting it, the buyers are cell manufacturers?
Largely, they are not cell manufacturers because if you say the supply chain, once these materials being extracted, so there is intermediate synthesizer. So battery manufacturers need the composite material. So when we will sell the lithium, cobalt, nickel, manganese, again the intermediate company will synthesize this material in a composite form.
So you sell in the salt form and they then reconstitute it, right?
Yes.
Right. And for you, the biggest raw material or the biggest cost of goods sold are the discharge batteries, correct?
Largely discharge batteries, we can't say that.
No, but do you keep them on your books? I mean, my point is that do you work like a solutions provider and say effectively do the extraction and take a margin on that? Or do you actually like buy discharge batteries, keep it on your books, treat it, and then extract and sell?
So we used to buy the whole batteries. We have warehouses to keep the batteries all over India. Then this battery is being discharged locally in the warehouse, and then the battery transported to Delhi to do a mechanical operation. So this is complete kind of manufacturing setup which we have done. Right now we are doing 200 metric tons of battery waste every month, which is equivalent to 22 million batteries, which we are recycling every month. That is the scale which we have reached right now. We are sourcing from every sector: electric vehicles, portable electronics, mobile phone, laptops, telecom sector. Big giants like telecom sectors, we are receiving batteries from them because now the problem of these batteries is being increasing because of the adoption of these batteries are increasing very high. And we don't have any solution in India to recycle these batteries because China has now banned these materials to import. China is not accepting any battery waste inside the country. So this waste is being increasing in India country year by year. That is something we need to now address to scale the plant to maybe 1 lakh metric ton, 1.5 lakh metric ton to resolve the problem of these batteries because these batteries contain very heavy elements like cobalt. And it can cause cancer and it can create a lot of problems in terms of water damage or something. So that is something that needs to be addressed in terms of problem solving aside also.
Right. What sort of margins at a manufacturing level do you see in a business like this? Is it like a classic 10-12% type of a business?
So in this, the margins are very high. It is more than 40% gross margins we can get. And net margin we can reach up to 25%, 30% because these materials are very, very costly. Even lithium we talk about. I think in July, in January, the pricing was $80,000 per ton. Or you can say $80 per kg. Cobalt, it was $68 per kg. So the pricing of these materials are very, very high. And we take these batteries in a form of waste. So logically, we are creating a black gold from the waste materials. So that is something which we are enjoying right now in terms of getting the higher margins.
So I mean, effectively, I mean, effectively, you get a deep discount on your raw material, right? Because these are discharge batteries, correct?
Yeah, we source based on per kg.
Right. Understood. And what's the what's the edge or the moat here, Vikrant? Because is it more because it's obviously there's a technological aspect here, there's a manufacturing aspect here, there is also a capital efficiency play here. I mean, this is a high capex business at the end of the day. So and it's I'm sure there are other lithium-ion battery recycling players in the market as well. Like we're just reading, like so for example, there's a company called Etero. I don't know how large they are. It sounded like they're fairly large, right? So I mean, when it comes to you guys and when it comes to Etero, multiple other companies, and I'm sure every company have their own set of process and technology patents also in place, one way or the other. But is yield the edge here? Is the fact that you are early adopters in this market, is that the edge here? How does it really work? So in this, we can take, there are two USPs or edges which we are getting right now. Definitely early mover advantage, definitely that's the edge. So which we will not count here because there are certain other like Loham is there, Atero is there, Exigo is there. Yeah. Certain other players are there. There are two modes. One is the technology and second is supply chain network. Mm-hmm. So that is very much important because the backbone of this business is supply chain. Once you build your plant on a larger scale, you need the regular uniform supply chain to run your plant more effectively. So that is something which we have built our digital platform to source the batteries from any parts of the country. Right. Second is we have channel partners in the country which source the materials on behalf of us. Third is we have our model works on hub and spoke model. Mm-hmm. So there are certain spokes. For example, this mechanical process I was talking about. Mechanical process we are going to set all over the country. So there will be 5-6 mechanical units. One is maybe in South and maybe Karnataka, Tamil Nadu, one in MP, then you have UP. So we will convert the batteries in powder form locally. Mm. And that powder will be brought to a chemical hub in Delhi. Right. So that is something, the network which we are creating that will give us higher yield and the better margins to recycle these batteries and get the proper kind of uniform material to feed in. Second, definitely technology which we have created, that is in-house created. We are not dependent on anyone. We have not taken anything from China. We have built this whole technology in-house. So we have a flexible technology because the major problem in lithium-ion battery is that you will see that every month there is some news about that this kind of lithium-ion battery is being launched, right? BYD, CATL, Mahindra, Tata, they are announcing that every month that the battery chemistry is being changing. So you need a flexible technology to accommodate future technologies also to be into the market in the larger game. So that is something which we are building in-house, our whole engineers, R&D team. So we have divided our whole team in 3 parts. One is the R&D team, which purely works on the R&D section daily in terms of creating the batteries, the future batteries out there will be recycled. The existing batteries, because India, if you take the technology from Europe or China, their technology will not work in India. Mm-hmm. Because the type of battery waste which we are receiving in India mixed with mud, silica, grease, and other materials. Right. So you can't solve with the manual segregation. You need a technology to solve that problem to mix with, right? And when you deal with the larger waste, you will be needing a technology which can be scaled up very, very larger section, like giga recycling centers or mega recycling centers maybe 5 years later. Mm-hmm. So that is the way which we are, technology which we have created, that is hydrometallurgical technology. So for example, we were leaching that paste. Mm-hmm. Once we get the black mass or the powder, we convert that powder in the liquid form. And then we do a liquid separation of metals from liquid. And then again, we precipitate the liquids, metals from the liquids to get it out in the salt form. So the technology is scalable. We have already patents on that in terms of process. And so that is the key IPs which we have created. 9 patents we have more filed on the similar section. Right. To scale the section on an industrial platform. Atero, if you're talking about Atero, they were already into the e-waste management from last 10 to 12 years. Yeah. That person is from Harvard and some other institutions. So they have diversified themselves from e-waste to lithium-ion at this point of time. But we are the alone company which are purely into the lithium-ion recycling. And if you see the export data of last year, we are the highest exporter of black mass from the country, right, from the export data. So in terms of commercialization and expandability, we are trying to
get the market share as maximum as, because this is a very niche field. You need to create your processes, supply chains, technology, exports, quality in a very best condition, because you have to export the material. So there should not be any quality degradation in terms of exporting the material. So that is something which we have created edge mark in this whole supply chain.
Got it. Does the global market for these metals differentiate between metal from the mine and ore and then versus a metal from a recycled battery? Does the pricing or do the buyers differentiate between that?
Not really. Actually, when you sell the pricing, there has been sold on two things. One is the qualitative analysis, second is quantitative analysis. So as if you have good technology, if you can match the quality, purity of the material to the mined material, there's no difference, because these materials are being sold on basis of the purity which is being there in the materials. So that is something which is important.
So what is sort of the way forward? I mean, it's a capital intensive business. There's so many positives in the story. You have the technology and processes in place. There is demand for these metals, global demand, we know, and there is an increasing supply for raw material as well, because that entire demand, essentially after a few, the lag becomes the input, right? So is it sort of just a game of scaling up, setting up more units and deepening the supply chain relationships and sort of just keep growing like that? Is that the play, or are there sort of horizontal areas that you think, we've got lithium-ion, now let's work it with some other battery composition, maybe sort of even not just sell metals, but maybe remanufacture a battery if we can? How do you think about long-term, medium-term growth?
So at this point of time, because there is no player in terms of India to supply these materials, and this is a very experiential game. We cannot put in a day one that we can build the cells. It will take some time to understand the material properties, the supply chain, the uniform supply chain regarding the critical materials of like lithium, cobalt, and nickel. At this point of time, we are supplying these materials to outside, but our whole major agenda is to supply these materials to Indian players. So we will also enter into the cathode material, which is called CAM, pre-CAM. So already the research we have started in producing the materials. For example, we mix that material again into a composite form with some new chemistry, maybe NCA chemistry, LFP chemistry, or any other chemistry. Yeah. We will produce that material and provide the manufactured cathode material to the cell manufacturer. Because ultimately they will import the material from China, especially the pre-CAM material. So we will be the ones who will providing the fully manufactured product to them to directly use into the batteries. And then after that, maybe we can collaborate to someone else, because we have the technology of cell manufacturing also. So we can collaborate maybe until after 2025, we can collaborate to someone as a technology partner to build the cells. But we will not directly go into the cell manufacturing. We will be limiting ourselves in the materials only.
Understood.
So the idea is to kind of piggyback on cell manufacturing, picking up domestically at some point in time.
So it's only, we have also got the grant from Ministry of Heavy Industries of 6 crores. That is purely for the R&D work of pre-CAM. Right. They have given the money so that they don't want to get out this material from our country, because it is a very critical material. It is this material you can consider like a gasoline, right? We're importing the gasolines. We are creating a physical deficit out of that, importing that, right? So government plan is that if you can restrain this material in the country itself, so that import of gasoline or this material can be reduced, so the physical deficit or the economy can be scaled up, because the future of energy is these materials, right? You can see that future is going to be electric. The power generation is going to be a material science based on renewable or maybe the materials. So after 5 to 10 years, you will see there will be a strong growth of these materials sciences energy, rather than the gasoline which we are using as a petrol or diesel or maybe some other materials to get into the in terms of strengthen the economy. And for any country, energy, you will see that energy is the backbone of the economy, right? So energy demand, if we are able to create in terms of renewable supply chain. So to cater that, we are the ones who will create the energy materials from these recovered materials. Also, we can buy the material from outside the country, like Indonesia, as a you can say ore, and we can refine the same plant and strengthen the supply chain of these materials to provide into the battery manufacturers. So that is something which we are trying to create, and that's something which we have thought that over the years we can strengthen our supply chain and the capacity of the finished materials, so that the bottleneck of these materials can be reduced down over the years, and this battery manufacture can be boosted by providing the material directly from our country itself. So that will make the whole India Atmanirbhar a self-independent or self-independent inside the country. You are not dependent on other countries to get the material out of the section. So that is something which we are trying to create, and that's where our whole journey, which we are trying to create in terms of providing the materials inside the country again.
I mean, effectively, yeah, that entire upstream, downstream narrative, which in a commoditized kind of a play like crude oil has happened 100 years ago. There will be parallels to this as well. I think because you mentioned the government, you mentioned the ministry. One question I wanted to ask you was on regulations front, because there are for example, in Europe, there is obviously two sets of rules, right? One is obviously on the need to recycle batteries, right? And on the other is there is also a circular economy narrative, right? That effectively existing batteries need to have recycled components. Where are we in that journey? Because I mean, as you said, there is hardly any domestic cell manufacturing. I imagine the latter is something which we are still not looking at that closely, but the former probably is.
So already the Indian government is very effectively looking into this area. So already it's called BWR, Battery Management Rules, already come into the place. It is being applicable in the country. So already two mandates are being given to these battery manufacturers. One is whatever the battery producers, they're producing the battery, that they're assembling the battery, it's their responsibility to recycle these batteries.
Yeah. Yes.
Right. This is called extended producer responsibility.
Right.
Second is whatever the manufacturers which are manufacturing the battery in the country, they have a mandate of utilizing the recovered material. At least 20% of this recovered material should be utilized into the new batteries.
Got it.
So that is a mandate, and they have to show the certifications to the government every year. They have to file the returns quarterly, that how they are moving with the battery waste which they are producing, and we are the authorized recycler for them who will give the certification to them. So how they are going to do it? They have launched an online portal where they will be tracking the battery to materials to extraction to new cells. And it is already being launched. It is being applicable, and now the whole compliances they have put onto the every OEM and the recyclers. So that is something which we have put on the front of battery management rules. Niti Aayog and Ministry of Mines, they have just launched the policy on these materials, especially the battery grade materials. It clearly states that they are regulating these materials to go outside the country. So they are incentivizing these players, the battery manufacturers. Already, I think if you're knowing the PLI scheme, production linked incentive to cell manufacturing is being launched of around 16,000 crores. To these, where Ola Electric, Amaraja, and other kind of companies got these PLI schemes to build the new cells. Mm-hmm. So already, government is trying to create an ecosystem of circular play. Mm-hmm. From producers to recyclers to new cell producers. Mm-hmm. And that's something they are incentivizing. They are providing a lot of, they are standardizing the protocols in terms of the regulates. Right. So that is very much important, that now the regular Kawadiwala cannot store the battery. Right. Mm-hmm. You cannot give your battery to unauthorized vendors. Mm-hmm. So that is something that will keep the trackage of these batteries and the materials from battery manufacturing to the extraction of the materials. So that is already being regulated and come into the picture, and that is being already applicable in the country.
Is it like you always know, like in government, the start is always a policy, right? But from policy, you need to actually have specific ordinances, laws, and bylaws in place to actually enforce. Where are we there? Is it more of a kind of a initial framework which has been laid out, and we are still waiting for, or you're actually seeing it in motion on ground?
It is already being action in terms of most forcefully action. So CPCB, for Central Pollution Control Board, is the regulatory body for this section. Right. And now any manufacturer, right now already they have sent the notices for battery producers. All the OEM, they got the notice from government that I want where is the certification of recycling, whatever the material produced years back. Where is the certification of PPR, extended producer responsibility? And now these players are actively looking for recyclers to make a tie-up, make a player where they can set up authorized recycler to recycle their stuff, and that is being applicable. The portal is being live, so producer and recycler need to be already they are registered on that portal, And if you are, for example, if you are giving 10 tons of material to recycler, you have to upload on the portal and recycler need to accept it. So that is being already applicable in a best of form. Definitely, there are some problems in terms of, because it's a new industry, certain regulation and standard will be revised maybe later time when the problems will come. But at this point of time, it is being applicable with the enforcement team. So that is something which is being created already.
Right. Last point, Vikrant, on fundraise. You've raised around, I think, 1.9 million to date. At least that was what came out in traction. Just want to understand from your standpoint where you guys are in terms of, scale, number one. Secondly, from a fundraising standpoint, I assume because it's a manufacturing play, credit also has a fairly important role to play here. It's not just equity. So how have things been on that front?
So we have raised 3 rounds till now. One was pre-series seed round, pre-seed round. Then we have raised seed round of 13 crores. And now we are raising pre-seed round of around 60 crores. So already this round is being completed mostly. And this capital which we are receiving will purely go for the working capital to rotate the supply chain. Right. And maximum of the capital will go for the capital plan. Now we are building the second unit, which is around 1,20,000 square feet, which is very large facility, where we are putting the first commercial plant of chemical extraction in a commercial form. So that is already the activity is being started. And so already the PE has come in this round. So largely a lot of lines are being opened from different government banks. So that is already being done. A lot of working capital in terms of debt we are receiving. So now it's because we have made some revenue from last 7 to 8 months. We have done a revenue of around 25 crores. Right. So that was something which we have achieved all right at this point of time. This year we are projecting around 100 crores of revenue in this current financial year, where maximum of revenue will come from the extraction, the chemical plant, in terms of extracting the material, exporting it to different countries. After building the plant, we will go for another round, which will be largely for expansion of these books, which I was talking about. That we are trying to build 5 to 6 more mechanical units all over the country. So that's how we are going to scale it up. Parallelly, we are very much focused on R&D, because R&D, we are already giving a lot of capital. We are spending a lot of capital on R&D side. A lot of laboratory, we are creating our in-house laboratory, because at this point of time, we were using the institutions, laboratories to research base, to test the equipments. Now we have already built 2 laboratories in the facility, where one is purely for the testing laboratory, second is the research. Now third laboratory we are building using the MHI, Ministry of Heavy Industry, which they are giving as a grant for researching the pre-cam material. That means converting that material to the battery material. So these 3 fronts we are already into the motion.
Thanks, Vikrant. This was super helpful and insightful. I wish you all the best, and for larger and more significant milestones in the future. And thanks a lot for your time. This is Nikhil Arora. With me, there's Sharat Tupran signing off.